Hey there, it's me, Miss B, and we are looking at today the Unit 5, Lesson 1 practice problems for Illustrative Math Algebra 1. So let's start here with question number 1. Which expression equals 2 to the 7th power? So what we're really asking is what does it really mean to say 2 to the 7th power? And that means we're multiplying it by itself 7 times. So that is going to be choice B here. 2 times 2 times 2 times 2 times 2 times 2 times 2. So it means multiplying it by itself. Just that many number of times. So for question 2, we have evaluate the expression 3 times 5 to the power of x when x is 2. So what this means is 3 times 5 squared, which is 3 times 5 times 5, because that 2 means we need to multiply 5 with itself twice. And if we multiply that out, we get 75. So that is our answer for number 2. Question 3, we have a graph. So it says the graph shows the yearly balance in dollars that in an investment account. What is the initial balance in the account is our first question. So the initial balance is what we're going to see right here where our graph is starting out. That is our initial value. So that is going to be $1,000. Question B says, is the account growing by the same number of dollars each year? And explain how you know. So we are going to say no, because if it was growing by the same amount each year, it would not have a curved shape like this. Growing by the same amount would give us a linear function. And if you look a little closer at the graph, I know you're probably doing this on paper, so you don't get a chance to zoom in, but we're growing by less than $500 right here each time. And then as we get up here, we're growing by like $1,000 each time, or definitely more than the 500. Oh yeah, each of these is 500. So we're barely growing by like 200 maybe on this first one. And then here we're growing by well over the 500. So we can say either of those things really, or both. We will say no. If it was growing by the same amount, it would be a straight line. We can say the first few years it grows less than $500 per year. And in the later years by more than $500. Okay. So question C here says that a second investment account starts with $2,000 and grows by $150 each year, and we want to sketch that account on the graph. How does the growth of balances in the two accounts compare? So we'll start this one, and I still got my red pen selected, so I'm going to start it at 2000. And if it's growing by 150 each year, that's going to be a little hard to show on here, but it's going to grow by 300 every 2 years. So let's see here. Okay, so if I have 150, it's probably going to be around, well, 300 would be around there, maybe. So 150 like here. And it'll generally grow by about that same amount. It's not quite going to land right there, but it'll be very close to that. I think it'll be just under where I put it. And that's 6. It should be just underneath. Yeah, so it'll be very slowly growing, sort of like this. I think we're actually going to at 10 years, I think we're actually going to hit exactly right there. So it kind of looks like this. Again, we're sketching, so we want to try to be accurate, but it's a little difficult when our scale is on 1,000 to go by 150. So year 11 will be just sort of just above, and then 12, yeah, sort of just above here. And 13 is like just underneath, and 14 is like just above. That's probably as good as I can get it. So I'll make these a little bigger so they kind of show where they're at. Also, because I think some of them I did a little too high, so I can adjust them down a little bit. But I'm trying to make them just so they're around the same size as my blue dots that they gave me on this graph, or just the dots that were given. So there's my sketch. So that is question C. So I'm going to say C graph. So that's where my answer is. So now we want to say, how does the growth of the balances in the two accounts compare? So the second account is growing by the same amount each year. And starts at a higher value. The first account, we're going to say it slowly grows faster and passes up the second account by, what year did it seem to pass it up by? It looks like by about year 9. Well, year 9 is when it kind of catches up, but definitely by year 10. By year 10. Sorry, I was looking at the blue one being just underneath right here, and I was like, yeah, the red one's above, but we're looking at when our red one finally becomes below. So it is year 10 if I'm describing that. Okay. So we're going to flip the page and go to question 4. Jada rewrites 5 times 3 to the power of x as 15x. Do you agree with Jada that these are equivalent expressions? And explain your reasoning. Well, first off, no, I do not agree. I cannot have an x and an exponent just come down and become a variable, but also they mean very different things. 3 to the power of x is 3 multiplying with itself. So the easiest way to do it is, or the easiest way to explain it is honestly plugging a number in that's more than just 1. So, I would say no, because it basically looks like Jada just brought the exponent down into the problem as one of the things we're multiplying by. So I'm going to say no because 5 times 3 to the power of x is not equal to 5 times 3 times x. And then if we plugged in numbers, we could show that. So let's say example where x is 2, 5 times 3 squared is going to be 5 times 9, which is 45, and 5 times 3 times 2 is 15 times 2, which is 30, and these two are not equal to each other. Okay, but really I would say that the red part is my explanation. I just like including some numbers just to actually show that no, it really does not work the same way. All right, question 5. Investment account number 1 starts with a balance of 200 and doubles every year. So we're doubling. That's nice, doubles every year. Investment account 2 starts with $1,000 and increases by 100 each year. So increases by 100 each year. How long does it take each account to double? How long does it take each account to double again? So we're going to say for account 1, 1 year, because it doubles every year. For account 2, it has $1,000 and it's adding 100 each year. So we need to figure out when it's going to have $2,000. And if we're doing 100 each year, that's going to be 10 years. So 10 years. How long does it take each account to double? Again, well, for account 1, it's just going to be 1 more year. For account 2, we're now trying to go from 2,000 to 4,000. So this is still only adding $100 a year. So now we're trying to increase by $2,000, so that's going to be 20 years. How does the growth compare? And explain your reasoning. So we're going to say account 1 will grow slow at first, but continue to speed up. Account 2 And let's talk about this 10 years and 20 years. It's actually taking longer to double. So account 2 will take longer to double each time, really. So it's actually going to take twice as long each time in order to double, because we would have to spend twice as many years since it only grows $100 each year. And now we're on to the review questions. So for question 6, we have this one. So Lynn says that a snack machine is like a function because it outputs an item for each code that you input. So we want to explain why Lynn is correct. Well, this is from all the way back for the very first unit that we did this year, so unit 4 in lesson 1, and that was that every function has one input, give one output. So we're going to say because every input, because each input only has one output. And that's our definition of a function. Each input only has one output. For question 7, we have a gas station problem. Okay, so at a gas station, a gallon of gasoline costs $3.50, and the relationship between the dollar cost and the gallons purchased is described with a function. So we want to identify the input and the output. Well, we then want to describe blank is a function of blank and identify an input-output situation pair and what it means. So weirdly enough, in this case, even though you would think I put money into the gas pump and gas comes out, that is not our input-output relationship. We actually would pump the gas, and then the gas pump tells us how much it costs. So, we are going to say that our input is gallons of gas. And then our output is cost. So blank is a function of blank. So in this case, we can say cost is a function of gallons of gas pumped. So for part C, if you really wanted to go super simple, you could say 1 gallon of gas costs $3.50, but most people don't just buy 1 gallon. I generally will put about 10 gallons at a time in my car. I think it holds 10 to 12, so let's say 10, and then if I said that was $3.50 each, it would be 35, so this would mean that 10 gallons costs $35. Wouldn't that be nice? So yeah, 10 gallons cost $35. And that is the end of homework assignment number 1. Just checking. Yep, not homework number 1, the Unit 5 Lesson 1 practice problem. So thank you for joining me. This has been Illustrative Math Algebra